Good morning. Welcome to the first session of mathematics. The name of the session is speed calculation. In this section, we are going to understand some of the basic principles of calculation in mathematics. We are going to start with the principles one by one. The first principle that we start with, suppose you have to multiply two numbers 72 into 78, 33 into 37, 12 into 18, 46 into 46, 92 into 98, 91 into 99. The first type deals with multiplication of two numbers where sum of last digits is equal to 10 and remaining part of the number is same. For example, when we have a look over all these questions, we can just say that sum of 2 plus 8 is 10 and the rest of the number is same. 33 into 37, so we can say 3 plus 7 is 10 and rest of the number is same. 46 into 44, we can say that sum of the last two numbers is 10 and the remaining portion is same. So for answering the questions of this type, our rule is very simple. Multiply these last two digits, 2 into 8, it will give you 16 and 7, the next integer is 8. 7 8s you will get equal to 56. We can again understand it. 2 into 8 will give you 16. 7 next number is 8. 7 8s are 56. Similarly 33 into 37. 3 into 7 will give you 21. 3 next number is 4. 3 4s are 12. 12 into 18. 2 into 8 16. 1 is the next number 2, 1 into 2, 2. 46 into 44, 4 into 6, 24. 4 is the next number 5, our answer would be 2024. 92 into 98, 9 into 2 into 8, 16. 9 is the next number 10, it would be 90. In the case of 1 and 9, we get it at 9, we make it as 0. That is the first exception. When we take our number as 91 into 99, my last numbers are 1 and 9. In that case, we make it as 09, 9 is the next number 10, it should be 9009. Same can be replicated to when it is a 3-digit number, 102 into 108. 2 8s are 16, 10 is the next digit, 11, we can take it as 110. If I say 200, 7 into 200, 3. 3 into 7, 21. 20 is the next number, 21. 20 into 21 will result in 420. So we can say our answer is said to be 42021. So I hope you have understood this. What this question states you, we have to multiply any two numbers where sum of the last two digits of the number is 10 and the remaining portion of the number is same. In these questions, what we generally follow, we just multiply these last two digits and we get a 2-digit number. In case where we get a single digit, we take it as 0, 9. That can only happen in the case of 1 and 9. Otherwise, you have to just multiply these two numbers, 16, then 7 is the next number, 8, and we can say 8 into 7, it will give you 56. So that is our first method by which we can multiply any two numbers where sum of their last places is 10 and the remaining section is same. After this, we will start with our rule number 2. Our rule number 2 talks about squaring of any number, squaring of Suppose you have to find the square of 15 or square of 25 of square of 75 or square of 95, square of 105, square of 115. In all these questions, we just apply our previous rule, like we have to multiply 15 into 15. अगर हम ध्यान से देखें तो we can say sum of the last two digits is 10 and the remaining section is same. So I can say 5 into 5, 25. Once the next number 2, it would be taken as 225. So same we can follow a rule in any question when we have to find the square of any number ending in 5. What we can do simply, just find the square of 5. This will give me 25. Once the next number 2, 1 into 2 will give me 2. It will be 225. Suppose you have to find the square of 25. 5 square is 25. 2 the next number 3. 2 into 3, 6. 75, 25, 7 8 the 56. 95, 25, 9 is the next number 10. 9 10 is the 90. I have to find the square of 105. 5 square is 25. 10 is the next number 11. This will give me 110. I have to find the square of 115. What it will give me? 5 square is 25 and 11 is the next number 12. 11 into 12, 132. Our answer is said to be 13225. So that is the first rule. That is a rule number 2 that will state you whenever you have to find the square of any number ending in 5, you are just expected to find the square of 5. This will be 25 and then multiply this number with its next integer and you will get the square of a number ending in 5. After this, we will try to understand a very important method with the help of which we can find square of any 2-digit number. That's a very important thing. But before explaining how to find square of any 2-digit number, first of all, we must remember square from 1 to 30. It's a precondition for you. Because when you appear in any of the competitive exam, you need at least some calculations which must be in your mind. That includes square of 1 to 30. And I hope everyone out of you know about square of 15. This will be 225. Square of 16. This would be 256. Square of 17, this will be 289. Square of 18, 324. Square of 19, 361. Square of 20, 400. After this, square of 21, 441. Square of 22, this is 484. Square of 23, this will be 529. Square of 24, 576. Square of 25, 625. Square of 26, 676. Square of 27, 729. Square of 28, 784. Square of 29, 841. And square of 30, this is 900. So before going further, first of all there is a need from your side to cram the square from 1 to 30, because these calculations will help you when you directly get a number 529. It comes in your mind that it is a square of 23. Now after this, we try to understand the method by which you can, without any hassle, without any problem, you can find the square of a 2-digit number. Suppose one 2-digit number is given to you as AB, where B is the last digit and A is the first place. And we have to find the square of AB. Whatever rule states, I think everyone out of you know the square of a plus b whole square. This takes you a square plus b square plus 2ab. We use the same principle. What this rule states, for the last place we use b square, for the middle place we use 2 into a into b, and for the first place we use a square. So what our concept says, whenever we have to find square of any two-digit number, that is ab, if we have to find the square, so what we can say, this a square, this would be 2 into a into b, and this would be b square. In every question of this type, we always start from the last. For example, we can try to understand this with the help of the examples. We can start with finding the square of 31. 1 square is 1, then we have to multiply 2 into 3 into 1. This will give me 6, then square of 3 will be 9. Our answer is 961. Just understand it again. 1 square will give you 1. Then for the second place we know 2 into a into b. It means we have to make 2 into 3 into 1. This will give me 6. Then I have to make it square of 3. This will give me 9. So I can say this will be 961. 32 square. My last place 2 square will give me 4. Second place 2 into a into b. 2 into 3, 6 into 2, 12. Now the first thing that you have to take care, I am getting 2 into 3 into 2. This will give me 12. I use here only 2 at this place, and 1 will go as a carry. Then I will make a square of 3. It will make me 9, and 1 is carry. 9 plus 1, this will give me 10. What the rule says, in applying this method, we have the 3 places, last digit, middle place and the first place. This place and this place must be filled with only a single digit number. And if we at any place we get a 2-digit number, same will be given as a carry. Similarly, I have to find the square of 33. 3 square is 9. Then 3 into 3, 9 into 2, 18. I will make here 8. Carry would be 1. 9 and 1, 10. The answer is said to be 1089. I have to find the square of 72. 2 square is 4. 2 into 2, 4 into 7, 28. 8. Carry will be 2. 49 or 2, 51. This is 5184. I have to find the square of 91. 1 square will give me 1. 2 into 9, 18. 8. Carry would be 1. 9 nines are 81 or 1, 82. The answer is said to be 8281. I hope this method is clear to you, because it's a very simple method, as well as it makes you to apply your mind in calculating or in adding the figures in your mind. We can take some more examples on this. Suppose you have to multiply 76. Now 6 square is 36, 6, carry would be 3. 7 6 are 42, double 84, 3 87, 7, carry will be 8, 49 plus 8, 57, answer is said to be 5776. You have to find the square of 84. 4 square will give you 16, 6, carry would be 1, 32 double 64 and 1, 65 5, carry will be 6, 64 and 6, 70. Our answer is said to be 7056. So this method is very simple, but this method can be applied when you have to find square of any 2-digit number, in which you are just supposed to do b square. The second place would be 2 into a into b, and first place would be a square. The thing that you have to take care in this, both places must be filled by single digit. If at any of the place you get a 2-digit number, same would go as a carry over the other number. Right? After this, I am going to tell you our next rule, rule number 4. Suppose if I mention you a number 124,864, and you have to multiply this number by 125. Although you can multiply because you know the direct method by multiplying by 125. But here I am just going to tell you we have four standard things: 5, 10, 5, 25, 125 and 625. Means whenever you have to multiply any number, how much big is the number? If you have to multiply the number either by 5, 25, 125 or 625, so what you can say, 5 simply means 10 by 2, that you know. 5 means 10 by 2, 25 means 100 by 4, 125 means 1000 upon 8 and 625 means 10,000 divided by 60. I think you know it very well. 5 can be taken as 10 by 2, 25 is taken as 100 by 4, 125 is taken as 1000 by 8 and 625 is taken as 10,000 by 60. So what you are expected to do, suppose you have to multiply this number by 125. We know that 125 is taken as 1000 upon 8, means I will put 30 here and divide this number by 8. And it is very easy to divide a number by 8. How? 8 ones are 1, 44, 8 fives are 40, 48, 8 6, 48, then 0, 8, 8, right? And after that 3 zeros are there. So I can say my answer is said to be 1, 5, 6, 0, 8, 000. Just try to understand it again. We know that 5 could be taken as 10 by 2, 25 can be taken as 100 by 4, 125 is taken as 1000 by 8 and 625 is taken as 10,000 divided by 16. In any question where there is a need to find the multiplication with either 25 or 125 or 625, in banking exam and other exams, a number of places you have to multiply your number by 25 or 625. In that case, you apply this approach. We can take one more example here. Suppose I state a number 1, 2, 8, 4. I have to multiply this number by 625. So we know it very well. 625 is taken as 10,000 by 16, means 4 zeros in the back, and divide this number by 16. We know that 16 8s are 128. That is the first step. Then I will take 4. I will put 0, 40, 16 to 32, 85. The answer is said to be 802500. It becomes my answer. Right? So this is our rule number 4. This helps us whenever we have to multiply any number either by 5, 25, 125 and 625. In these cases we can apply this approach because it is very easy to divide a number by 2, 4, 8 or 16 instead of multiplying the same number by 625, 125, 25 or 5. So that's our rule number 4. The next is rule 5. This rule deals with 3 standard identities. Before going to this rule, I just want to ask some questions from you. Can you answer this? Under root of 1, 2, 3, 4, 3 to 1. Under root of 1, 1, 1, 0, 8, 8, 8, 9. Or you have to find the value of 9, 9, 8, 0, 0, 1. In number of exams, either in bank PO, CAT exam or other competitive exam, you find these 3 questions. They may be of some different type, but in all the 3 questions, we have to apply 3 standard identities. I am going to start with one by one. Our first identity start with 1 square is always equal to 1, 1 square is always equal to 1 to 1, 111 square is equal to 1, 2, 3, 2, 1. What this identity talks about, suppose I have to find the square of any number containing all the 3. 1, 1, 1, 4, 3 times. All ones, so 1, 2, 3, then 2, 1. Similarly, 1, 1, 1, 4, 4 times. Answer should be 1, 2, 3, 4, 3, 2, 1. Means I have to write my counting up to 4 and then 3, 2, 1. If I say 1, 1, 1 is going for 5 times, answer should be 1, 2, 3, 4, 5, 4, 3, 2, 1. This can be extended up to 1, 1, 1, 4, 9 times. Suppose I have to find the square of this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. It becomes my answer, right? So how we can apply this? Look at this question. Our statement is under root of 1, 2, 3, 4, 3, 2, 1. When you observe this statement, you can simply say that would be taken as 1, 1, 1, 1, 4 times whole square. This would be cancelled out and our answer is said to be 1, 1, 1, 1. That's our answer. I think the first point is clear to you. That's our first identity. We have to find the square of any number containing all the ones and maximum it goes up to 9 times 1. After this, we will understand the second identity, that is based on the rule of 3. 3 square is 9, 33 square is 1089, 333 square is 110889. What this identity talks about, when we have to find square of any number containing all 3 in these questions, what is our process to answer? We have all 3 for 3 times subtract 1 means 2. I will write 2 times once, then 0, then 2 times 8 and in the last we use 9. For example, I have to find the square of 3333 and I have to find my answer. So my answer would be taken as 1, 1, 1, 4 times 3, so I will use 3 times once, then 0, then 8, 8, 8, 9. If I say 3, 3 is used for 6 times and we have to find the square, so my answer is taken as 1, 1, 1, 1, 1. 6 times 3, so I will take it as 1, 1, 1, 4, 5 times, then I will put a 1, 0, then 5 times 8 and in the last I will take it as 9. That becomes my answer. So this identity can be applied in this question where it is asked from you under root of 1, 1, 1, 0, 8, 8, 8, 9. By looking at this question, I can take it as under root of 3, 3, 3, 3 whole square. My answer is said to be 3333. That becomes my answer. So that it is second identity based on the similar lines when we have to find square of any number containing all the 3. Then we have third rule that applies on case of 9. We know that 9 square is 81, 99 square is 9801, 999 square is 998001. When you look at this point, now we will find the square of any number containing all the 9s. If we have to answer this question, what we will try? Subtract 1 from the given number. 999 minus 1, it will result in 998. Then I have 2 9s here, put 2 zeros, in the last you have to use 1. If I say 9999, I have to find the square. My answer will be 9998, 000, it should be 1. 999 for 6 times. We have to answer it. So I can make it as 99998000001. Means I have to subtract 1 from the given number. This will give me 999998. Then 5 times and in the last I have to put 1. It will state my answer. Now if I look at this question, what this question states to me, 998001. It simply means I will just make it as 999 square and my answer is said to be 999. It becomes my answer. So that is our rule number 5 that talks about these three standard identities which are applied on rule of 1, 3 as well as 9. In number of exams you may find a direct application of this question. It may be in the form of finding of the square root, or at any place you are expected to find the square of these terms, and with the help of these properties you can easily answer it. So that is our rule number 5. After this, we will discuss the rule number 6. When we consider this rule number 6, this rule talks about multiplication of two specific numbers. For example, 25 into 35, 45 into 55, 75 into 85, 95 into 105, or 125 into 135. When you look at these numbers, what you will find, last places of these numbers are 5 and the difference between the starting numbers is equal to 1. Our next rule talks about when we have to multiply a pair where last places of the number is 5 and the remaining portion of the number is differed by 1. Suppose 75 and 85, this is 5 and 7 and 8 में कितना difference है? 1 का. 95 and 105, what we can say? This is 5 and the difference between 10 and 9 is 1. 125 and 135, we can say the last places are 5 and this is 13 and this is 12. So I can say the difference is equal to 1. If you have to answer any question of this type, what the process talks about, just put 75 in the last two places and out of 2 and 3, which one is greater? 3. And the first place would be taken as 3 square minus 1. Answer is said to be 875. Try to understand it again. You have to multiply 25 into 35. Our last two places would be 75. After that, what I will do, square of 3 is 9 minus 1, 875 becomes my answer. Similarly, I have to multiply 45 into 55. My last two places are 75. After that, 5 square is 25 minus 1. My answer is said to be 2475. You have to multiply 75 into 85. Last places are 75. 64 minus 1, 63. Answer is said to be 6375. You have to multiply 95 into 105. What you will do? Last places are 75. 10 square 100 minus 1, 99. Answer is said to be 9975. 125 into 135. I will put here 75. Then square of 13 is 169 minus 1, 168. So that is taken as our rule number 6, in which we are just understanding how to multiply any two numbers where last places of the numbers is 5 and the remaining portion of the number is differed by 1. So in these cases, we can simply make it as 9 minus 1, 8, and at last two places I will write 75. My answer is said to be 875. I hope the point is clear to you. After this is the last rule of this session, that is rule number 7. This rule talks about use of some basic properties of natural numbers. I hope all of you know about the concept of natural number. When we consider the natural number, all of us know that 1, 2, 3, 4, that goes in such a way. My counting always starts from 1. The first principle talks about sum of first n natural numbers. Sum of first n natural numbers, 1 plus 2 plus 3, it goes up to n. Answer is said to be n into n plus 1 divided by 2. When you have to find sum of first n natural numbers, so you can say n into n plus 1 divided 2. Similarly, second one is sum of squares of first n natural numbers, means you are supposed to find out 1 square plus 2 square, that goes up to n square. The answer should be n into n plus 1 into 2n plus 1 divided by 6. And third rule talks about sum of cubes. Sum of cubes of first n natural numbers, 1 cube plus 2 cube plus 3 cube goes up to n cube. So this would be taken as n into n plus 1 divided to complete whole square. This rule can be applied when you find the counting starting from 1, because this applies sum of first n natural number, and we know that the first n natural number is 1. Suppose you have to answer 1 plus 2 plus 3 goes up to 20, so your answer would be n into n plus 1 divided by 2. So answer is said to be 20 into 21 divided by 2. 2 will go at 10. 10 into 21, answer is said to be 210. In the similar way, I have to find the square of 1 square plus 2 square plus 3 square. It goes up to 10 square. So here I will apply my formula number 2, n into n plus 1 into 2n plus 1 divided by 6. So I will take it as 10 into 11 into 21 divided by 6. 2 will go on 3, 2 will go on 5, 3 will go on 7. Then I can say 7 into 5, 35, and 35 into 11, answer is said to be 385. So we can say the product is said to be 3, where we can say that sum of the square of this number is said to be 385. We try to understand few more applications of these 3 standard formulas. I hope you have noted it down so that we can start with further portion. Suppose you have to find the square in between. I have to find 7 cube plus 8 cube plus 9 cube up to 15 cube. I have to find the square of, I have to find the cubes of these numbers starting from 7 cube plus 8 cube up to 15 cube. So if you have to answer any question based on this, what you can do, you cannot directly apply that formula because my counting is not starting with 1. So what I am expecting to do, I will start with 1 cube plus 2 cube up to 15 cube minus 1 cube plus 2 cube up to 6 cube. That I will subtract. Now if I just understand this, I know the formula for this, n into n plus 1 divided by 2 complete whole square minus n into n plus 1 divided by 2 complete whole square. 2 will go on 8. 15 is 120, this would be 120 square minus 2 will go on 3, 3 sevens are 21, this is 21 square, so 14400 minus 441. You have to subtract this number out of this, so you can say your answer is said to be 13959. It becomes your answer. I hope the idea is clear to you now. Means if you have to find the square or sum of the cubes or sum of the squares in between, then in these questions what you can do, you just take your counting from 1 cube to 15 cube, then subtract the starting portion 1 cube to 6 cube. In both cases you can apply your formula n into n plus 1 by 2 complete whole square and just simplify. Your answer is said to be 13959. That is our rule number 7. I hope you enjoyed this lecture of speed calculation 1. In this lecture we have studied 7 rules of calculations. In the next lecture we will try to understand some more rules of calculations so that you can enjoy study mathematics, because when you have to study mathematics The keyword for that, you must be good in your calculations. Most of the mathematics is based on the calculations. Without good calculations and accurate calculations, you cannot work in an objective multiple choice questions, because here you get marks only when your answer is right. It nowhere matters whatever step you use to answer it, whether they are right or not. But if you are getting your right answer in the minimum time, it means you are going to crack the examination. Thank you.